All right, in the previous two problems, we've looked at how the interest rate and the length of term of a loan increases your cost. If you have a higher interest rate, you pay more. If you take out a loan for a longer period of time, you end up paying more, especially over a long period of time. Let's do a few more calculations, talk a little bit more about loans, in particular auto loans. So let's suppose that we picked out a new car and have agreed on a price of $29,900 with the salesperson. And now it's time to go into the financing department. And currently in the dealership model, this is really where the dealerships try to make their money, is on the financing of the car. They don't mark up the price very much as they used to from the dealer, and so they really want you to finance that car because that's where the money comes from in that financing. The person in finance is going to go in with two goals. One goal is to make you borrow as much money as possible, and the other thing is to make the length of the loan as long as possible. Those will both increase the dealership's profit in there, the money they earn from them. So we have a price of $29,900, but there's a lot of other things we need to remember. We have the sales tax is about 10% here in Washington. You also have to pay for licensing, registration, tabs, to get the license plate put on your car and get it officially registered with your state government. And of course, they also add in extra things like there's a mysterious document fee of $150. And are you interested in that extended warranty? No extended warranty? Okay. So they have a few extra things, dealer destination charges, other things to do to hike that price up to get you to borrow more money. But one of the first questions you'll be asked is how much do you have for a down payment, and what is your goal for a monthly payment? And so let's suppose that we have $8,000 for a down payment, and our goal is monthly payments of about $500 a month. So, advanced slide, there we go. Let's do some calculations. So our purchase price was $29,900. Sales tax here in the state of Washington is 10%. 10% of $29,900 would be $2,990. Registration in tabs, let's go with an estimation of $400. I'm doing that based on a vehicle that I currently own. It's not very new, but I'm guessing that's what it is. I tried to look on the Washington State website, Department of Licensing website, to see if I could find if you could put in like the model of your car and tell you how much the tabs were going to be. And I could not find that, but there's something out there that kind of gives you an adjustment somewhere. Dealers have some way to look it up. And they always round that number up, by the way. It might actually cost only, $350 to do the license and registration, but they're going to start off with a $400 fee in here. And if it does come back as only costing $350, they'll mail a check for $50. But you financed the full $400, and so you're going to be paying interest on the $400 for the 5 or 6 or 7, however long the loan is, you're going to be paying interest on that. So they always round that up. That's another little place where they make a little bit of money. It's hard to look that up to kind of counter that. You need to know the VIN number for the car, as well as the name of the registered owner. And if it's a new car, it's never been registered, so that doesn't exist. So that's kind of tricky to get that numbers from the state with our current system in the state of Washington. There's a doc fee of $150. I don't know, they've started adding that in the last 5 or 6 years. I'm not sure why, but it's there. And so if you add those numbers up, our total cost is $33,440. We're going to make a down payment of, say, $8,000. And so that leaves us $25,440 to finance. Now, a lot of times in math books, we leave out all this extra stuff, and we get criticized it for math teachers. We're not teaching you how to do things in the real world, and the problem is a little bit with that is, textbooks typically they have a national market, and the sales tax rate and the tabs rate, all that stuff differs from state to state to state, and so they can't really put it into one textbook in there. So that's a little bit of a discouragement. But a lot of times we get down to this dollar amount here and show you how to work with that. But there are these other factors that in math class we don't talk about, but are really going to be there that you're going to look at when you go to finance a car, when you go to purchase a car. These are the other fees in there. Those are pretty typical what I've listed here, but that's other things, And then they add extra things, dealer destination fees and service extended service warranties or service agreements kind of thing in there. So let's look at that. All right. So our end result is we're going to finance $25,440 at 5.18% interest. We'll assume that based on our credit score, that's the interest rate we're getting. And we said our goal was payments of $500 per month. And so let's do that calculation to start with. We're going to start with our present value annuity formula. Again, it's still a loan. You've got that large amount of money that's earning interest, and it's slowly going to pay down to zero in there. So that's a present value annuity through our regular payments in there. So plugging in what we know, our PV, our present value, is $25,440. The payment, the R value, is $500. The interest rate is 0.0518. And making monthly payments, so M would be 12. And then I'm going to put, instead of the MT up there, I'm going to put in a big capital letter N. That's kind of using the book's formula. And N would be the total number of payments that we're going to make, or the total number of months involved. So that's kind of what we're looking for here in this question. So first thing I'm going to do is I'm going to start and divide both sides of the equation by 500. So let's divide by 500. Divide by 500. Those will cancel out, and we'll get 50.008 in there is equal to all this other stuff. Okay, next step, I'm trying to again solve for n. I'm going to work my way out. Let's get rid of this bottom. Let's multiply both sides by 0.0518 over 12. Do that, of course, to both sides of the equation, 0.0518 over 12. That will cancel out of the bottom. And we will get something like 2.19632. Now, it's really important not to round if you can. Use all those numbers in your calculator in there, or avoid using them at all. Okay, so the next thing I need to get rid of is the 1 out in front. And I'm going to do it a little bit different. I'm going to add the 1 plus 0.05184, that section divided by 12. I'm going to move that to the other side, and I'm going to subtract this over. I'm going to swap sides of the equation with those pieces, subtracting on there. I want to get that n term positive in there. So that's what we're going to do. And then if you subtract, do the subtraction, we get 0.780368 in there. And now the trick is, now my variables appear in the exponent. The last thing I need, I've got it isolated, something to a power. And so I'm going to use a natural log. I'm going to take a log of both sides of this equation. And that allows me to bring the exponent down and multiply it out front. So I'll have negative n times the natural log of 1 plus 0.0518 over 12 equals the natural log of 0.780368. And then to get n by itself, we divide. To get n by itself, n is being multiplied by the natural log of stuff, so we'll divide by the natural log, and we'll come up with this for our n value. And let's go plug that into our calculator. Let's see, it was the natural log of 0.78, I can't remember, 0.780368, 0.780368. Close that off, divide by the natural log of, whoops, I need a negative sign in there, negative the natural log, and be sure to use the negative, not the subtraction key, of 1 plus 0.0518 divided by 12 in there. Okay, and then let's do those and do that calculation, and I get negative 57.325. Why did I get negative? Oh, I put in a minus instead of a plus. Huh. Does it really make that big of a difference? This should be 1 plus 0.0518 divided by 12. So let me go in and change that. That's a nice feature there. I don't know if you've caught that on the TI. If you push the second and then the enter button, it pulls up the last thing that you typed in and you can go back and edit it. Very useful when you're working with a really long equation like this to do that. Very, very useful in there. Okay, 57.57. There we are. That's the right number. Didn't make too big of a difference, but 57.57. So that means that it's going to take 57.57 payments or 57.57 months to pay off the loan. All right. And of course, now we have a choice. Do we want to go with, typically 57 months is kind of a weird term, or 58 months is kind of a weird term for a loan. And so what we will do is the finance officer is going to come back and say, well, do you want a 48-month, they're going to crunch the numbers for you, a 48-month or a 60-month loan there, a 4-year loan or a 5-year loan in there. And for car dealerships, they always do it in terms of months. They never talk too much about years, so 4 years or 5 years. So that's our question. Next question that we're going to have is, what are the monthly payments for each of those two options? And how much you're going to pay in total for those? And what's the difference in those? All right. So again, using the present value annuity formula to work those out.